Right. We're going to be studying geometry. Not really studying, but just having fun with it. The whole idea is to get you exposed to some of the things related to geometry before school starts. And part of doing any sort of tutoring is to think about your goals. And so I'd like to ask you, what are your goals for the next few weeks for this series of study sessions? What do you hope to achieve?
To master geometry as best as I can.
Okay. Well, you won't master geometry. The study sessions are supposed to work in conjunction with your regular class. So by itself, this isn't going to make you master geometry. But hopefully what we're trying to do is give you enough exposure, a heads up on certain things so that when you do take the class, it'll be easier and things will make more sense. And that's the point where we're hoping you would have mastered the geometry. I'm not going to try to teach you everything. In fact, a lot of what we do here isn't the official, formal, proper, strict standard way of approaching things. It's just a different informal way that's supposed to help make sense, help the class make more sense. Okay, so you won't master it. You'll be exposed to it. You'll have a good idea about some important things, and then later on, hopefully, when you actually take the course, it'll be easier and you'll master it. Okay, so that's what I would say. Okay, what else were you thinking about getting out of it?
I don't know.
Okay. Let me tell you what I think would be good for you to get out of this, because it's a cram course, if you will. So, there are a few things, and only a few things, that I want you to get out of it. One is, I want you to be able to know what a few theorems, and know how to pick up a book and read a theorem and understand what they're talking about. Because geometry is about a bunch of theorems. I don't know how many. It's probably you probably need to, by the time you finish the course in school, you probably need to know 100 or, over 100 theorems. There are a whole bunch of theorems or statements that you'll need to know. And it's helpful to be able to look at the wording and know what they're talking about. And part of the problem, one of the main limitations of geometry, is you get these theorems, these statements, and they're very complicated and you don't know what they're talking about. So I'm going to try to teach you how to pick up a theorem, pick up your book, read a theorem, and figure out what they're talking about. So that's one thing I think is important. That way, in fact, you can read ahead of the class when class starts. Okay. A second thing that I'm going to work on is problem solving. Okay. Once you learn the theorem, the basic principles, a theorem is like a basic principle, a basic statement. A theorem may be something like, theorems and axioms and postulates. Those are basic statements, or some of them are very basic and the axioms and postulates are very basic and foundational and fundamental. And the theorems are a little bit higher level, because you combine the axioms and postulates to get theorems. But in any case, they're both just statements of principles. One may be, the angles of a triangle add up to 180 degrees. Okay, so that's the concept or the principle. Now you have to use it to solve a problem involving triangles. So not only am I going to teach you how to read a theorem, understand what they're talking about, but I'm going to teach you how to solve a problem using basic ideas and basic axioms, postulates, and principles to solve a problem. So I have this thing that I call the general problem solving procedure, which is going to be helpful in geometry. And in fact, now after you learn it, you're going to go back and be able to solve more algebra problems more easily than you used to last year. And it's going to be useful in other courses, and in fact, it's going to be useful in life, because it's a way to start out with a goal and figure out what you need to do to get that goal or to answer the question, okay, and then work your way backwards to given facts. So we're going to work on problem solving. And finally, we're going to work on proofs. We're not going to be expert at proofs, because I'm not even an expert when it comes to proofs. And the thing about proofs, too, is the level of detail that's required will vary with the book that you're using or with the teacher. So we're just going to touch a little bit on it. But, you know, after you go through these sessions, you'll at least be better prepared for the upcoming school year. And if we can do that, then that'd be great. Now, in terms of a book, it doesn't really, right now I haven't really settled on what book we're going to use. I would say most books that I've seen sort of cover the same topics, even though they may cover it in a different order, or they may emphasize different things. So I think for now, just follow along the sessions with your own book. Just find the chapter in your book that covers the topics or the issues that I bring up, and just follow along on your own, okay? So you should have brought paper and a ruler and a compass, even a protractor. But for now, a ruler and paper should be something you bring to every study session. Of course, a pen and a highlighter. A highlighter is good, because the thing about geometry is that sometimes you'll have to draw or figure out something that involves all these complex polygons, figures all interlaced with each other, and so you'll have to highlight certain parts of it to understand what's going on. So let me just grab my paper. Let me get some paper. Okay. All right. So, like I said, it doesn't matter which book you use for now. But just try to follow along in terms of topic. Okay. This book that I'm using defines geometry as a branch of math that studies the shapes of objects. It doesn't really define, but it just makes a statement. It says geometry is a branch of math that studies the shapes of objects. It also says that geometry also studies the sizes of objects. So it basically talks about different aspects of geometry, though it doesn't really give you a definition of it. So I would like to ask you, in your opinion, what's geometry about? What do you think about geometry?
I think it's about shapes.
Okay, so you think about shapes. Okay, I would say the same. It's about shapes. I would say it's about space and spatial relationships. Algebra was about abstract, turning real world things into abstract symbols and talking about the relationship between those symbols and principles that the symbols represented. Okay, so that was algebra. Geometry deals more with space and how space is used up, and the relationship between different things with respect to the space that they take up. Okay, so taking up space includes, if you're talking about what space does a triangle take up, you have to talk about the shape of a triangle and the size of a triangle, right? So the geometry talks about figures and the space that they take up, and so it touches on the size and the shape of those figures and certain properties of those figures. Like an angle between different segments, or that's formed by different segments. So those are sort of informal definitions or informal descriptions of what geometry is about. Okay. So let's look at some of the other things that they talk about here. They talk here about attributes of figures. Those are different things. Let me just, before I go into attributes, let me just make some notes here on things that we covered. So we talked about the definition of geometry, and what did we say?
Space.
Study of space, or figures, particularly their shapes and sizes. Okay, so that's our rough working definition of geometry. The other thing, now that we know that it's about figures and their spatial properties, let's look at some of the attributes of figures that these people are talking about. So I want you to tell me, what are some of the attributes of figures? If somebody draws a figure on a piece of paper, what are some of the things that would be important in your mind?
It has to be a closed figure.
No, I'm just saying okay, so the fact of whether it's a closed figure and an open figure, closedness, closed or open figure, okay? So those are things that stand out when you look at a figure. What else?
I don't know.
It could be the number of sides. So number of sides, whether it's shaded or not. Color, they're just, when you see a figure, there are different things that you notice. And, I'm not so much interested in listing all the attributes of a figure, but I'm interested in you being able to see how different figures are similar, whether they're similar or not, and just noting which ones are similar. Now, a few exercises. Angles. Do you know what an angle is?
Yes.
Okay, what's an angle?
Two rays joining at one endpoint.
Right. That's right. Two rays joining at one endpoint. So, or as I would say, two lines that come together at one point like this. So this is the angle. You have two lines. As you correctly identified, the two lines are really rays. Okay, they have an endpoint or a beginning point, and then they just go out forever. This is an angle. Now, angles can be classified based on how big the angle is, the degree measurements. Do you know what I'm talking about? I think you should have done this in pre-algebra. Okay, so how can you classify angles just based on the degree measurements? What types of angles are there?
Acute.
Okay, so you got acute, and what's acute?
Less than 90 degrees.
Okay, less than 90 degrees. Okay, what else?
Right angles.
Okay, so what's a right angle?
Exactly 90 degrees.
Okay, so it's equal to 90 degrees. Any other kind of angles?
Obtuse.
Obtuse. Okay, what's that?
More than 90, but less than 180.
Okay, greater than 90 degrees, but at the same time it's less than 180. And?
Straight.
Okay.
It's exactly 180 degrees.
Okay, and that's 180 degrees. Okay, that's good. Well, you know, okay, you said, okay, acute is less than 90. What if it's 0? Beats me. Okay. All right. So let's move on to certain other attributes. I'm going to show you, or I'm going to sketch a couple of figures. I'm going to sketch some figures, and then I'd like you to talk about, then we'll pick a couple of them and try to determine what attribute they have in common. What is it about them that makes them similar? Okay, because again, part of geometry is recognizing similar properties among different types of figures. Now, I'm not the world's best drawer, but it doesn't matter. So I'm going to draw four figures. So that's the first one. I'm sure you can probably draw better than me. So what kind of figure is this one? Do you know the name of it?
Rectangular prism.
My goodness. Where did you learn all these things from? You should be tutoring me. Where did you learn all these things from? You just remember them from a couple of years ago?
Yes.
Wow. You have great memory. This is a little bit messed up. So what I want you to, so let's call this one A, and let's call this one B. Let's call this one C. Let's call this one D. So if somebody were to say, what's the common attribute between C and D, what would you say?
They're both three-dimensional.
Okay, good. But so is everything else, actually. Okay, what else? Pretend these are properly drawn straight lines. Okay, what else? What else would you say is? What are common attributes between these two?
They don't have triangles.
Okay. And what's the significance of that? Do you know?
No.
Okay, actually, this is probably better drawn like this. This is better drawn like this. Okay, what about A and B?
They both have triangles.
Okay. Triangles where?
On one of the faces.
Okay. Okay. All right. So, what about A, C, and D?
I'm not sure.
Okay. What about B, C, and D?
They all have rectangles on at least one of their faces.
Okay. All right. Okay, if somebody, okay, so B and C, do you see that B and C are prisms? Do you remember prisms?
Yes.
Okay. And you remember pyramids?
Yes.
Okay. So what's a prism?
I'm not exactly sure.
Basically, you have a polygon here at the base and a polygon at the top, and they're parallel to each other, right? And then they're connected, then the vertices are connected. So a cube is a prism because you have this rectangle, a square base and a square top, and then the corners are connected by straight lines. So, and then a pyramid is, a base, and then from the vertices, from each vertex on the base, they go up. You draw a line, and they go up and meet at one point, right? That's a pyramid. So those are different ways of classifying objects. Okay, so I think we should just take a break. I like to take a break every 30 minutes or so. Take a break for 3, 4, or 5 minutes, and I think we should take a break. Okay?